So let's graph the square root of x. All right, we already know how the graph of the square root of x looks, right? If you scroll to this page, you see that the square root of x looks like this. So what we're trying to do is determine how this graph, this function gets its shape, right? So again, we're going to do a t-table. Do a t-table. All right, we're going to pick out some x values that we think will be best to put in this particular function. All right, and then we're going to figure out what our f of x is once we plug in x. All right. For example, what numbers would be okay to plug in the square root of x? Let me ask this question. Would negative numbers be okay? Yes or no? So answer that in your head. Would negative numbers be okay? Actually, no, for this particular function, because we have the square root of x. And the domain of this function are numbers that are not negative, right? The domain, if we plug in negative under the square root of x, like a -1, then we end up getting an imaginary number. Now we haven't been to the imaginary system yet. We're still in the real number system and not the imaginary number system. And you will learn the imaginary number system. I think that's section 2.4, so that's coming up. But now that we're just in the real number system, we're not dealing with those i's. And some of you have been in pre-calculus before, so you understand what I mean about the I equals square root of -1. But we're not there yet. So we're going to plug in numbers like, what numbers do you think would be good to plug in? All right. So think of some numbers you think would be good to plug in. Write them down really quickly. And then I'll go over what I think will be good. Okay. All right. You can pause the video if you want to. But I'm going to go ahead. All right. 0 to me works just fine. 0 under the square root is just fine. All right. Because I'm going to go ahead and write everything out. Because the square root of 0 is 0. Right. And then I'm going to write this as a point. All right, the point is 0, 0 for that one. All right, 1 would be good because the square root of 1 is 1, right? So 1, 1 would be great. All right. Now, do you think 2 would be good? Okay. Now, if you want to plot this quickly, it would probably be best to skip 2 and skip 3. And go to 4. All right. And you probably say, why did you do that? Because, anybody know? Well, it is a perfect square, right? The square root of 4 equals 2. So 4, 2 is applied. The square root of 9, for example, is 3. So 9, 3 is a point on the graph. Now, if you had plugged in 2, let me insert 2 in here. We plugged in 2. We have the square root of 2 equals what? So use your calculator to determine what the square root of 2 is. Now the square root of 2 is 1.414, something like that, okay? Approximately 1.4. So 2, 1.4 is a point. All right, so let's plot these points. We have 0, 0. All right, we have 1, 1. 2, this was where you start to see it curve. 2, 1.4 something. 4, 3, 4, 4, 2. So you're starting to see the curve here. And 9. All right, that's 3. So let me erase that. 1, 2, 3, 4. 5, 6, 7, 8, 9, 3. So here you see that curve. All right, I'm gonna put an arrow because it continues forever to the right. All right, so if you compare this graph to what it really looks like, you see that it is the same. And again, notice how it goes off the graph, which means that it continues on and on forever to the right, which means that the domain of this function is 0 to infinity and a bracket at 0. All right, let's go on to D. It is a constant function. Constant, right? We have a number. So f of x equals 4. Therefore, y equals 4. So if we do a t-table, we know that all of our f of x's are 4s. All right, no matter what, f of x is 4. It's telling us f of x equals 4. We can't change the value of y because it is constant. All right, it's never changing. It has to be 4 no matter what. And you can decide on what you can plug in for x, right? You can decide -2, -1, 0, 1. And since it's a line, then technically you only needed 2 points to draw that line. But let's plot this. -2, 4. Go to the left. Go up 1, 2, 3, 4. Then we have -1, 4, 0, 4, and so on. But when you draw your line, always either go off the graph or indicate that it continues on and on forever with arrows.